Hi, everyone. Nice to meet you. I'm Dr. Michael Struwig, so I'm the head of AI for OpenBB. And like Michael kind of mentioned, we're going to look at quite a bunch of things, specifically how LLMs are being used in finance. But what I actually really want to do today is something a little bit more interesting. I want to start from essentially the beginning and show you everything from maybe not the nitty-gritty details, but I want to start with all of the necessary information you need to understand how these LLMs work and how GPTs work and how to think about them, and then how to use them to build copilots and agents that actually solve problems. And along the way, we'll touch on all of the kind of important prerequisites that you need to understand. And so the idea isn't so much to overwhelm you with information, although there is a lot that we're going to go through. It's more to just kind of send to you and give you a bit of a compass and a map on how to think about these things so you can, build your own solutions. And along the way, we'll show you like how OpenBB works and why it's quite a nice playground for developing copilots and things like that. But let me share my screen and then we'll take it from there. There we go. All right. So how to build a financial copilot. That's really what I want to talk about today. So before I start, I think it makes sense to do a bit of an introduction into what OpenBB is about. So we are neck and neck tied as the most starred financial open source project on GitHub. This is the OpenBB platform, and that is essentially what powers the entire data layer behind our OpenBB workspace, which is our web app, which is what you see on the right-hand side. We are a global, fully remote team. So we have people across, I think, 3, maybe even 4 different continents. And we're all coming together to basically build this radical vision that we have on what we think the role of financial analysts and data analysis will be, generally speaking, in a post-AI world. I think what makes us a little bit different to a lot of the other commentators and other people building stuff out there is we don't believe the future is AI replacing humans. We see the future as AI and humans working together to do the same tasks that they're currently doing, just faster and more effectively. And also, one of the things that's quite nice is I'm South African. I'm talking from Cape Town in South Africa, and it's really just good also to represent, the African continent on the global stage. And so just a little bit about me as well. So I work as the head of AI at OpenBB, and I'm essentially leading the AI team in building out Copilot, and also kind of guiding the company and our team on building the best kind of AI integrations into what we're trying to do to help achieve our vision. So with that being said, let's kind of dive straight in and talk about the fundamentals of LLMs and how they work. So I'm sure everyone is familiar by now with ChatGPT or Claude or all of these various kind of AI services. Essentially how they work is they're instruction-tuned LLMs. And so you can add in prompts or instructions, and then you get a stream of outputs, which should hopefully answer the question that you have. And so this is really amazing technology. You can ask for general knowledge questions. You can ask them to perform tasks for you, ask them to write code for you, and they can do all of these amazing stuff. And so the question is kind of how do these things work anyway? So GPTs are the primary architecture for large language models. This stands for Generative Pre-trained Transformer. The transformer part is something that was actually introduced by Google, I think in around 2016 or 2017. So we're nearing in on 10 years old now for the idea. And it was made famous in this paper called Attention is All You Need. And essentially, the attention mechanism and transformers were a solution to recurrent neural networks which weren't able to handle long-range dependencies. And the attention mechanism essentially allows us to do this. I'm not going to go into the technical detail of how the attention mechanism works. If you just Google, there are plenty of videos on YouTube and articles on Substack and Medium and places like that that will explain it better than I can. But the important thing is that GPTs use the attention mechanism, and this opens up long-range dependencies where you can answer questions for things that were mentioned much earlier on. You don't have to worry so much about the fact that most of these work as a decoder-only architecture, but the key thing to understand is that they predict one token at a time. So what do I mean by predicting the next token? So imagine you have the following sentence: the cat sat on the, and now you have to predict the next word. Just intuitively, as humans, we can notice that the words cat and sat are quite important. And if we take a look at those words and give our attention to them, like the attention mechanism would, we can come up with a distribution for what the probabilities of the next word are. So we see we have quite a high probability that the next word would be Matt. but it could also be floor or bed. And essentially what we do is we look at this distribution and we sample from it. So essentially we roll the dice where there's an 80% chance of it coming up with mat, a 15% chance of floor, and a 5% chance of bed. And then we kind of sample from that, and then we get mat as our next token. So let's look at another example. So look at the following sentence. Michael really likes pizza and Kirst really likes pasta. This means they both like food from, and now I have to predict the next token or the next word. So we can see again, like just intuitively, we see that pizza and pasta are like the most important words in the sentence probably, maybe food as well. So we can draw up our distribution of what we think the next token should be. And we see that Italy has the highest probability. And so now we have to sample from this distribution. If I had to change, pizza to baguette, suddenly we draw a slightly different distribution. So now we see, okay, it could be France, it could be Italy, it could be Europe. Maybe there's a small chance of it being Germany or Sweden. We can never rule things out. But again, we've changed the distribution based on all of the previous words. And then we sample from this distribution and we end up with France rather than Europe. So what's going on here? The important thing to understand is we sample from the distribution. Now you can tweak in the way in which you sample from the distribution, but the point is there's always a 20% chance that France will come up, a 20% chance that Italy, and a 50% chance that Europe will come up. And the important thing to understand is that the distribution that we get for the next token, it's computed from looking at all of the previous tokens and all of the previous words that were in the sentence. And this is a really important point to understand, right? We sample from a distribution, and that distribution comes from looking at all of the previous words. And when you're dealing with LLMs and you're building with LLMs, everything is about shaping that distribution so that the words that we sample are the ones that we want. And this is basically what prompt engineering is all about. It's about modifying and manipulating these distributions that we get out to be in the shape that we want in order to give us the answers that we need. And so we've just looked at predicting one word at a time or one token at a time. What happens if we want to generate paragraphs or text? Well, the solution is essentially we turn everything into a next token prediction problem. So we start off with one word and we predict the next one. And then we append it to all of the words and we look at these two words, then predict the third one, and we just keep going. So then we look at all three words, predict the fourth one, all four words, predict the fifth one, and so on. And so this trick with generating really beautiful, coherent paragraphs and text is, well, we just look at the chunk, predict the next one, add it together, and just keep on going until we're done. And so to just make it a little bit more concrete, we can look at the following example. So we start with the word there, we draw up a distribution, and we sample a word from that distribution once. Then we see that we have the two words there and once. We pay attention to there and once, we draw up another distribution, we predict was. There once was. Suddenly was is the most important word because these have been trained on huge swathes of data. And if we understand English grammar, we know that typically after was comes a, and then we sample that. And then this process essentially keeps on continuing. We look at all of the words that we've predicted, we figure out which ones are important, we draw up our distribution, and we sample from that. And that's how we essentially build up, these bodies of text. And like I just mentioned, shaping these distributions is really an art form. It's scientific in some ways, but as someone who spent, probably hundreds of hours prompting these things now, you get a feel for how they work. It's not really a scientific process where you say, well, in order to get the behavior we want, I need to have these specific inputs. It's very much something you build an intuition and a feeling for. And it's really a skill in and of itself to shape these distributions. And I would say, we look at people in the financial domain who use OpenBB Copilot and these LLMs, and we realize that a lot of them really just don't understand how prompting works and how to shape these distributions. And from our experience, you need typically between 10 to 15 hours playing with ChatGPT to get a feel for how they work. And, if you want to build with LLMs, before you do anything else, I would highly recommend you basically choose one. It doesn't matter which one. Choose ChatGPT, choose Claude, play around with Gemini, doesn't matter, just choose one. They're all pretty much on the same level of capability. and then spend 10 to 15 hours asking them all kinds of questions. Figure out what they can do, figure out what they can't do, try and integrate them into the workflow you do every single day. If you're writing code, ask it to help you generate code, figure out where the limits are and where the breaking points are. I keep on harping on about this because this is kind of like a tacit knowledge. I can't give you a book on how to ride a bicycle and you'll know how to ride a bicycle. You kind of have to just hop on and build an intuition for how things work. Scientists still today argue about how bicycles are able to balance. Don't try and approach it from a scientific way. You have to learn what people in the industry call the vibe of how to treat these LLMs and how they behave. And again, don't skip this step. If you don't have an intuition for how the LLMs behave, you're going to be hopeless when you're trying to build systems with them. It is a fundamentally new kind of stochastic or random system that when you poke it in a certain way, it behaves in another way. You have to build the intuition for how these things work. Okay, so that's in a nutshell kind of how these LLMs work. But the next thing we need to do is talk about function calling, because I'm sure you've seen across social media and across all of these blog articles, a lot of people talk about, okay, so we've just improved function calling, we've added function calling to our LLM, and now we're way better at doing function calling. So what the hell is function calling? So essentially the idea behind function calling is LLMs are really useful if I give them a question and they can give an answer to me. But what happens if I want them to be able to take actions in the real world or be able to interface with external systems? So I don't just want to have, ChatGPT maybe tell me about what's on my shopping list. Wouldn't it be cool if it could actually go and buy something for me? Can I kind of hand the wheel over to an LLM and have it do tasks for me? And that's what the idea is behind function calling. So again, it's just next token prediction, but it's next token prediction in a very special output format that can give us some interesting guarantees if you use things like strict mode and stuff like that. But that's kind of irrelevant. The point is, rather than predicting the next token, which are words, imagine if the next tokens we were predicting were a special kind of format that tells us which function to call and what inputs to add to that function. So you still need to handle the execution of the function call yourself. It's not like GPT-4o or Claude or any of these models run the function for you. They just tell you, hey, I want to call the function with these input arguments. But the key thing to take away is with function calling, we can connect LLMs to external systems that we control and systems that already exist. And this is the kind of key takeaway you need to have. And what's nice about function calling is they allow us to abstract away lots of complicated things from the LLM. So you can think back to good programming principles. We don't really care about how something is implemented. The implementation details are hidden away. All we care about is what it accepts as input and what it produces as output. And this is really important when it comes to building advanced copilots and connecting subsystems together. All you need to explain to the LLM is, if you want to do a certain task or take a certain action, give me these inputs to this function and I will give you this output. And all of this complicated mess and all the complexity is essentially hidden away. This is really important because when you think about shaping distributions, it makes it easier to tell the LLM what to do when all it needs to know is what are the inputs and what are the outputs. And again, we use function calling to connect systems together, right? And what's fascinating is these systems can be other LLMs and other systems that are driven by LLMs. So you can build this cascading tree of, I have an LLM that can call a subsystem via function call that itself is an LLM that can do other tasks. So before we kind of talk into how these things work, I'm going to demo OpenBB Copilot to you. So one thing to know about OpenBB Copilot is, or OpenBB in general, you can sign up to it. You can use it for free. We have a generous free tier that allows you to use 99% of the important features, and you can sign up to this and play around. So let me just make this smaller. All right, so this is OpenBB. Essentially what it is a dashboard where you can bring in all kinds of interesting data. You can arrange your various dashboards that you have. I have a bunch of ones that I'm going to show off today, but let's just assume we've landed and we have this data. And now we can see we have things like news, structured data, we have historical prices, we have earnings transcripts, we have price targets by analysts, and we have earnings histories. And, I can add in a whole bunch of different data from the various widgets, and I can also bring my own data. So this is what OpenBB looks like. The magic happens over here for us. So over here on the side, we have access to OpenBB Copilot. And OpenBB Copilot is essentially this financial copilot that will help you do all kinds of analysis. So just to give you an idea, I'm just going to say, hello, introduce yourself. And so we can see we essentially have this chat interface that we can use to interact with OpenBB Copilot. So what can we do? Let's start with something interesting. I'm going to add the historical stock price widget as context, and I'm going to say, give me a line chart of the closing price of Apple. So essentially, we submit this information across to OpenBB Copilot, and then OpenBB Copilot can actually produce a graph for us. Now, a lot of interesting things happened in here. We showed the reasoning steps, so we can actually see the thinking process that OpenBB Copilot does. We see that it processed some data, it produced an artifact, and then it displayed it here. The other thing that we do is we have to have a citation to show you where the data came from. So in this case, we can see we used this widget in order to provide the answer. The other thing that's really interesting is we don't just have to produce charts, for example. I can say, let's say, give me a table of the weekly closing price for Apple, let's say the average weekly closing price of Apple for 2024. And what's interesting is all of these things that we produce, we can also pull them out as data and add them to our dashboard. And what's also pretty interesting is if we happen to be on an empty dashboard or a dashboard that doesn't actually have the right data available, Copilot is also smart enough to go fetch it for us. So for example, if I said, show me a plot of the closing price of Box and Dropbox for 2024, Copilot can actually go search through all of these data sources that we have. It'll automatically find and retrieve the right data, and then it will actually do what we ask as well. So here is a chart of the closing prices for Box and Dropbox, and that we aren't just limited to structured data, of course. If I come here and I actually have a PDF, I can also say, please summarize this document for me. And then we can query user files, we can produce summaries, and we can do all kinds of things like that. So this is quite a lot of advanced and complex behavior. We can fetch data, we can manipulate data, we can produce charts, we can produce summaries, we can pull these out. Everything is cited, things like that. So let's jump back to the presentation now that we know how Copilot works. And let's answer the question, okay, so how does all of this work? We can do things that something like ChatGPT struggles a little bit to do. How are we able to do it? And so let's talk about the main execution loop. So how OpenBB Copilot works is it basically have this main execution loop, which you can think of as a state machine. And we accept in all of the previous messages in the user's prompt, and then the LLM can take a bunch of actions. It can either choose to execute function A or function B or function C, or it can stream back the final answer if it's got all the information that it needs in order to do so. So let's say I added in a prompt, and in this case, the prompt was, create a line chart for me. Well, then what the main execution loop will do is we'll use an LLM, it'll make a function call, and it'll say, okay, I actually want you to execute function B with these inputs. And then we drop into function B's execution loop. And it turns out that function B itself is another execution loop driven by an LLM. And inside of this loop, the subsystem can choose whether it wants to execute function B1 or B2 or return the result. And so what happens is essentially we have this main execution loop. We get a function call into function B. Function B itself is an LLM-driven execution loop. It can produce a result, and then we pass that back to the main execution loop, and then we run the system again, and we can choose what to do next. And an example of this is the document subsystem when we produced a summary. So we started in that main execution loop. Based on the prompt, the LLM was able to determine that we need to query a document. It then dropped into the document subsystem loop and passed in the file and the query that it needed to use. This subsystem loop was able to say, hey, I actually need to summarize the document. It executed that function, returned the result to the subsystem loop, which returned the result to the main loop, and we generated the new completion, and we're able to stream back the answer. And so you have this branching tree of state machines where you can dig down, and each little subsystem has a dedicated kind of task that it can perform. So every subsystem is task specific, and all of these various subsystems work together to fulfill the wishes of the main execution loop, which is trying to answer the user's query. So you can think of this a little bit like a brain. Your brain has dedicated subsystems. Some of it goes towards making sure you keep breathing. Other parts of it are dedicated to vision and helping you see, or helping you hear, or helping you taste and helping you smell. And you have this kind of orchestrator that works together to pair all of these inputs to give you your perception. And so you get this emergent behavior, which is where you have these systems that are following really simple rules, but when you combine them together, you get this really complicated behavior that can do stuff that looks very, very complex from an outsider if you don't understand how it works under the hood. And this is how you get, buoyed behavior when you see very beautiful, complicated behavior from swarms of fish or birds or insects as they busy fly together. All they're doing is following very low-level rules, but it manifests as something quite complicated. And that's the same thing that kind of happens as you build these state machines together. But it's worth asking, why does this work so well? And really, it's an abstraction pattern. It's like what I was saying earlier. It's very similar to how good system design works. So you have the specialization of subsystems. They're all really self-contained. The complexity is abstracted away. What makes this really nice is, as a developer, you can test all of these in isolation to make sure they do the right things. And then you can compose them together to build like an advanced Copilot. And so doing this, you end up with something that's actually greater than the sum of its parts. Okay, so that's kind of the fundamental understanding, but what does this look like in code? So now we're going to move on to the workshop proportion of this, which is how do you build a Copilot? What we're going to do is we're going to build a Copilot that can use a code interpreter to do analysis. So we're going to write a Copilot that can actually generate Python code, and we're going to then execute that Python code in order to do analysis and manipulation of data. And then we'll send that data back to the main execution loop, and it'll actually be able to produce an answer for us. And we're going to integrate this directly into OpenBB, because one of the things I didn't mention is OpenBB fundamentally, we're a open core company that believes in open source. And so we want you to be able to bring any custom Copilot you have and have it integrate beautifully into OpenBB and do all of the stuff our Copilot can do. We'll be using GPT-4o as our LLM, and we will be running the code on your computer. So no external system necessary in order to run the code interpreter. Before we start, because I know this has been a little bit of an information overload already, we don't need to panic about this. All of the code that I'm showing you is open source and will be available. We have this open source repository called Copilot for OpenBB that has all of our custom Copilots that are there to encourage people to build them. All of this will be available, including the one I'm going to show you now. We document everything really nicely in that repository too. So what I really want you to focus on is, instead of understanding the specifics of how the code actually works, just focus on understanding the idea. I want you to really understand the concept of what we're doing from a code point of view, and not so much, what does this line of code do precisely? Writing this took me, like half a day to do. It'll take you a little bit of thinking if it's your first time doing it. So just focus on the concepts and then go take a look at the implementation later. The code is documented and there are comments and everything's laid out quite neatly. So don't panic if there's stuff here that you miss. Just try and get the bigger picture. So this is what the architecture looks like. We have OpenBB here. And what will happen is the front end, when you submit a query, will send a request across with the messages and the context. We'll capture that and send that through to the main execution loop inside of our custom Copilot. If necessary, we'll do a function call with the generated code that the main execution loop will create for us and the data to the code interpreter. We will execute the code, return the result, and if the main execution loop chooses, then we'll stream back a result using SSEs, which I'll get to in a second, back to the front end. So it's going to behave largely how you saw OpenBB Copilot work, and we're just going to write our own version. The tricky bits that you might not be familiar with is how the API works, what the hell SSEs are, and how the main execution loop works, and we'll go through each of these slowly. So just, briefly on the tech stack, we'll be writing this in Python. The API framework is Fast API. The LLM framework is Magentic, which is something a lot of you might not have heard about. You'll be familiar with things like LangChain or Llama Index. I think Magentic is quite a lot better, and that's why I'll be using it, but I'll be covering that. And then we'll also be talking about server-sent events. Let's ignore the fact that it's Python, and let's ignore the fact that I'm using Fast API. Those aren't really the interesting bits. The interesting bits is how do we program the LLM and how do we communicate back to OpenBB. All right, so let's start with Magentic. Magentic is my favorite LLM framework. We're actually using this in production at OpenBB. And how it works is quite interesting. Essentially, you take a function, a normal Python function, and then you decorate it with things like the system prompt and the human prompt and the AI messages, and you decorate the output using a typend for what the structure is that you want out. And then you can just call your function in Python code, and you're actually calling an LLM. This is a really nice pattern because it treats an LLM like the stochastic runtime you can submit to, but it's just a great way of treating an LLM call as if it's a function. And you can add functions to this to do function calling, like to connect systems together. And it's as simple as just writing a function and adding it to the function's input argument on this decorator. And now your LLM can call functions. This is how I can call GPT-4o. It's that easy. So I encourage you, it's also an open source framework. Go look at the documentation, but this is just the shape of what the code looks like. Essentially, we have this decorator and we decorate a function, and then we can do a completion with an LLM. The other thing we need to talk about are server-sent events, or SSEs. So basically, this is a way of allowing a client like the OpenBB frontend to make a single HTTP request, but we can stream back a whole bunch of events. This is how you get the beautiful streaming effect, because if we only can predict one token at a time, we don't need to wait for all the tokens to be done. We can just stream back one at a time, and then the user can at least read while tokens are being streamed in. You can read up about SSEs. They're not that difficult to understand. The important thing, though, to grasp is that they have a type and a payload. So over here, you see we're streaming back message chunks, so one letter at a time, or one token at a time, if we're using the right lingo in this case. And then we have the payload, which is the data that the front end needs to parse and handle. The interesting thing is OpenBB supports a lot of different events. So you can send back things like tables, charts, those status updates and reasoning steps that we saw, and citations, of course. So the front end supports a whole bunch of different events. And as long as your custom Copilot sends back the right events in the right format, we'll be able to render it and show it. Okay. Now let's talk about the actual code in the main execution loop. So in the code, this is the main execution loop that is responsible for doing the function calling, executing a completion, all of that stuff. This is actually the only LLM specific part. So you can ignore everything that's blocked out right now. So what we see is we have a main execution loop. We'll run it for a maximum of 10 cycles. Here is where Magenta comes in. You see we pass in our system prompt, all of the chat messages so far, so the ones that the LLM has completed, as well as the ones the user has sent through. We append through our LLM run code function, and then we can pass in context. And what we do over here is we just run the completion. And if it's a function call, we handle the function call and we append the messages. And if it's a streamed message, we stream those back and then we end. And that's it. That is our custom Copilot. Fundamentally, at the core level, this is how OpenBB Copilot works as well. That's all you need to do to build this behavior. So all of the magic is hidden around a couple of key points, and we'll go through each of these. The first is, well, how do we handle the context? So when OpenBB sends us data, how do we process it and put it into a shape that the LLM understands? The other is, how do we actually run the code? How do we deal with the result of the code? And then how do we stream back the messages? So we'll go through these piece by piece. The first is understanding how we handle the context. So over here, we have the system prompt. It's not particularly impressive or special, but essentially, we just let the custom Copilot know what it is, what guidelines it should follow, and how the code interpreter works, and a couple of guidelines. But the key point here is this context. So we need to be able to inject in the various pieces of context that the front end sends through. And this is how we do it. So in this function, we have the prepare context function. It takes in the context, which is literally just, a list of some raw text, and we just process it. We give it a nice name if it happens to be structured, because we want to put it in a pandas data frame for the code interpreter. And we just build up, a string of hints for how to use the context and what it consists of. And then we just return this. And this part, this little context prompt string, which we've just accumulated by looping through all of the pieces of context, this is what we inject in the main LLM loop, and it just gets essentially copy and pasted in place here. So this will say things like, hey, I've got the historical price table for Apple. This is what it looks like, yada, yada, and puts it in here. And then the code interpreter LLM function, so that's the actual part that runs the LLM code. It really is just this. Essentially what we do is, in another process, we spin up a code interpreter called the REPL worker, and we just send through the code that the LLM wants to execute, and then we return the results. The code interpreter is a little bit more complicated. This is just for the curious. You don't need to understand this. Just understand that Python is cool. It's an interpreted language. So if I have a string of something that looks like Python code, I can run it dynamically. So this is just, just for interest's sake, how this works. We inject a couple of the utility functions that allows the LLM, if it calls these functions, to return things either as a table or as a chart. And then what we do is we essentially evaluate the code either as statements or expressions and capture and return the result. But you don't need to worry about this. The important thing is code comes in and the result comes out. And that's the only thing you really need to understand with the function. One important thing is we do have this doc string over here. This tells the LLM how to use the tool, which is essentially run code. And then if we do actually end up using the code interpreter, we need to handle the function call result. So all we really do here is we take the result, which was returned as JSON, we parse it, and we just put it in a format that we know how to wrangle. But it's really, really simple. And then once we've done that, we essentially just add the function call, and we add the function result, and then we send it back to the LLM. So we kick off another loop in the main execution loop. And then streaming back the messages, it's really simple. You just see we yield these events. We stream back the events where we specify the type and just the data, like we saw earlier. And you saw the reasoning steps. That's really just this part that I blurred out. Essentially, if you yield a service sent event in the right format, we can add in things like these reasoning steps to say we're running the code and what the code completion is and the data that we rendered and stuff like that. But that's just bonus. You don't have to worry about that too much. And so that's kind of how it works. So in about 200 lines of Python, you can add a custom copilot to OpenBB that can accept in messages, and it can execute code, and it can produce the result. So I'm going to demo this. Let me just quickly show you how this all works. And all I have to do is let's just run this. Let's stop everything. We'll just run it from scratch. All right. So let's come here. I'm going to just show you how to add things from scratch. So right now I have the custom copilot. It is running locally on my machine, and the only thing I have to do is add it to OpenBB. So we do that by coming down here and saying add copilot. I just need to add the endpoint. And now we have the code interpreter copilot, and it's been added to OpenBB, and it can do all of the same things essentially that our OpenBB copilot can do. So I'm just going to say, hi, introduce yourself. Okay, and I've just called it Kevin because I thought that would be a funny name, but we have our code interpreter copilot that has now been added. So let's test this out. What I'm going to do is I'm going to add the historical stock price as context. And now let's ask Kevin something interesting. Let's say, calculate the average closing price of Apple. And now we see what will happen is this custom copilot will execute this code. We get the result from the code completion, and then it basically gives us the answer. So what happened is this code was generated by the LLM, submitted to the code interpreter. We ran the result, we returned it back, we restarted the execution loop, and now we have our answer. So let's do something interesting. Let's say we have Apple, and let's set one to Microsoft. And now let's do something interesting. So I'm going to add both of these and say, calculate the correlation of the closing price for Apple and Microsoft. So let's see how highly correlated these are together. So we're going to run some code, and we see that the correlation is actually really high. It's 0.8, which is quite big. So that's quite hectic. I don't know, what else can we do? Let's add a price target analyst widget. And oh, yeah, this is the right one. And you know what? Let's say, show me a bar chart of the average price target per firm. There we go. So here we get our bar chart of the average price per analyst. And of course, we can pull this out as a widget as well. Let me just make it a bit bigger. And you can see here we have that. And what's amazing is all of this code is being executed locally on my machine, right? It's just running through the interpreter that gets spun up. And there we have it. You have a custom Copilot that can run code and do pretty interesting analysis, like calculating correlation and doing statistics and stuff like that, the actual OpenBB Copilot is not that great at doing just yet. And this will be available for you to add to OpenBB, and then you can use it yourself in addition to, our Copilot. All right, let's continue. And so that's kind of, the whirlwind tour. I do just think it's worth mentioning, like, the rabbit hole goes much deeper than this. There's a lot of stuff that I've left out. There's a lot of subtleties that we can't go into in a talk of this length, because I think it's a little bit of information overload already. So we've only just scratched the surface. What I'm really hoping is this will give you the confidence to go ahead and actually build these things yourself and play around with them, since it only takes you about 200 lines of Python, admittedly some clever Python, but only 200 lines of Python, and you can have really sophisticated behavior that can interact with all kinds of different data sources and do analysis. So hopefully this kind of orientates you in the world of LLMs and how to think about them. So that was a lot. We covered how GPTs and LLMs work. We looked at next token prediction, the attention mechanism, how to shape distributions. We also spoke about how function calling works and how it allows us to connect subsystems together and how we can stack these subsystems to get really advanced behavior. And then we built a custom Copilot that can execute code and showed how we can integrate it into OpenBB. So thank you very much. That's kind of the end of my presentation. I'd also encourage you to check out our open source code at OpenBB and sign up for OpenBB for the workspace of the app. It's free. You get to do 20 free completions a day. All of the features I showed you work. And if you add in your own custom Copilot or bring in your own API key, you can use it as much as you want. And take a look at our docs and away you go. And you can actually add all of OpenBB platform as data sources to the actual app as well. So that's where I would go. We built our entire reputation on making this available as an open source library and a product for people like you who are looking for financial data to use.